Welcome. Today's video is on graphing systems and inequalities. We're just going to do a little review of the inequality rules and how to find a solution of two equations. A system is two or more equations. I could actually do as many as I need to. We're going to start with two. And we're going to graph the first equation. So I'm going to go ahead and start at 3, go up 2 over 1. I'm going to go ahead and put several points on the graph because it makes it easier to find the actual intersection point when you do that. Let's graph the next equation here. It's going to be the one with the 6. And we're going to go down 1 over 1. And I bet you just saw where the intersection point is going to be. The intersection point is the actual solution of the system of equations. So once I find the intersection point, I can go out. I've got 1, 5. I can go out and write down what the answer is. I'm looking for the point where they intersect. If the quizzes or tests ask you to graph, this is the way you need to do it. And then later on, we'll solve systems using the algebraic methods. Okay, let's go over inequalities first, and then we'll graph some inequalities. So if I were graphing, let's go 2x plus 3 again, and let's say we had an inequality symbol in there. I would need to know how to graph that line using the inequality. So we're going to go over inequalities. We're going to talk about less than, greater than, less than or equal to, greater than or equal to. What happens when you have a less than symbol? You're going to shade below the line. Okay. Also, the line has to be a dashed line. It cannot be a solid line. All right. If it's greater than, you're going to shade above the line. And it has to be a dashed line still. Okay. Now, the less than or equal to is still a shade below, but this time it's a solid line. And greater than is a shade above the line, and it's still a solid line. And we can plug in points to see if they work, and if they are true when we plug in them, then we'd see that where we're going to shade. Let's also talk about one more thing. If you have a solid dot on your graph, then that does mean that it's equal to. Okay. If you have a open circle, then it means it's not equal to. All right. So let's go on to our equations. We're going to do the same equations before. We're going to add one more equation in there. So I'm going to go, starting at 3, I'm going to go 3 up 2 over 1. Notice I'm making several points again, not just a few, so that I can actually see what this is going to look like. And then I'm going to go to 6, down 1 over 1. Notice that my lines are solid lines because it's an equal to on this. Okay. And then I'm going to go to x greater than negative 2, which is negative 2 is right here. Okay. Now, I like to graph all the lines first because then that's going to show me where I'm going to shade and where I don't have to shade. Because I want the shaded areas to intersect. I don't want to shade more than I have to. So on the first one, 2x plus 3, I'm going to shade below it. That means I'm going to go to the line and I'm going to shade underneath it. Watch where I'm going to shade here, because I know that the blue line is going to be shaded above. Okay, so on the blue line, which is the negative x plus 6, I'm going to shade above it, which means I only want to shade where the other areas are intersecting. So there's my negative x plus 6. And then I'm going to shade to the right of negative 2. Really shading to the right of negative 2 is going to be the right of the green line, right in here. But I don't want to shade here because that's not where the shaded areas are intersecting. I still need a shade to the right of negative 2, but I'm going to only shade right here. Okay. All right, so when you're doing your quizzes or your test, make sure that you're showing where the shaded areas are intersecting. Okay, now notice that I also need a dashed line on this negative 2. Not that it really it matters right now, but what I can do is I can go in. A lot of times what I'll do is I'll make that a dotted line and then I'll erase some of the line, or I'll go in and I'll make it dashed. Okay. Also notice that if I asked you for solution, then we would need to talk about where the solutions are. So for instance, if I asked you if there was a solution out here, if this was a solution, you would say yes. If I asked you for here, you would say yes. I mean, it doesn't really matter as long as it's in the shaded intersection area. So if I said, is this a solution of these three equations, you would say yes. If I asked you if this was a solution, because it's a dashed line, you would say no, because it's not in the shaded area and it's on a dashed line. Okay, dashed line means not equal to. If I asked you if this was a solution, even though it's a solid line, you would say no, because it is not part of the shaded area. All right, so just look for where the solution or where the point meets all the conditions. In other words, if this one right here, okay, if I asked you about this point right here, we're going to 3, 3. If I said, is 3, 3 a solution? Okay. Is it below the red line? Yes. Okay. Is it a solution of the blue line? Yes, it is. Is it to the right of x greater than negative 2? Yes, it is. So if I asked you if that was a solution, you would say yes. Okay, that's it for systems and inequalities. The next video on systems is solving equations algebraically. So I'm going to end here and we will see you next time.